Good morning, my students. I hope you and your families are doing well. This is going to be my first screencastify, so we're going to see how it goes. So today I am doing the first week's work of the Unit 9 genetics unit. So this will be the part that I said I recommended that you do sorry about that, on April 16th and 17th, but I know it's a little late. It is what it is. I'm doing it now. So first thing you need to write down is the key term genetics. So genetics is the study of heredity and genes. So just so you guys know, this isn't like the classroom. I am not going to wait 5 minutes for you guys to write this down. So feel free to press pause whenever you need to and resume whenever you're ready. Okay. So second key term, gene. So segments of DNA on chromosomes that code for a certain trait. So this is a chromosome. This particular spot here that this is indicating, that area will code for something very specific, such as hair color, how tall you might be, and other things such as that. Third key term, trait, genetically determined characteristics. So traits are things that are determined by your genetics. Your hair color is determined by your genetics. Your eye color is determined by your genetics. The pigmentation of your skin is determined by your genetics. Whether you go out in the sun for 10 minutes and get tan, or you go out in the sun for 10 minutes and get burnt, that's determined by your genetics. Oh, box A, record your ideas. So for this box, you're going to think about your experiences and do your best to answer this question. So, how does DNA from two parents work together to determine an offspring's traits? So, you are a combination of your mother and your father's genetics. They combined to create you. Now, I'm sure you guys are thinking about your parents and you're thinking about how different you are. Okay, so what do you think needs to happen for your DNA from your mother and your father to combine to create you? Take a second, record your ideas. Okay, box B. So this is what we've already figured out. Obviously, we are not in a classroom. These are not going to be your normal class ideas where everyone raises their hand and adds something. This is like the model box, so make sure you leave space for additions later because we're going to be adding on. So what we know, we've already figured out, is that parent passes only one of each pair of chromosomes to each offspring. And random chance determines which of the two chromosomes is passed to each other. So this is called independent assortment. Okay, so these two parents, this lovely couple is having a child. The mother is contributing an egg. The father is contributing a sperm, and each of those have two. So 2n equals 46. So each of these have 1n, which means each of these sperm have 23 chromosomes. They then combine to create 2n equals 46 chromosomes for a zygote, which could then grow on and turn into a fetus. So, phenomenon. This is a wallaby. There is something different about this wallaby. Wallabies aren't normally white. They are suffering from a genetic disorder called albinism or albinoism. This can occur in almost every single species. I've seen it in turtles, fish, humans, ducks, but typically these are noticeable or distinguishable by their white fur or skin, lighter fur, skin, and red eyes. So this happens when there is a lack of pigmentation. So we're going to be talking about traits and why they are the way they are. So to help us make sense of traits in our families, we are going to do the work of a genetic counselor. We are going to work with the family to see if there are any patterns that might help us understand how that trait is passed down in the family. To map this out, we will be using a family tree or pedigree. So pedigree basics. So square equals male, circle equals female. A black square or circle means that they have the trait that we're tracking. When there's a line connecting them, that means that there is a mating and that there is going to be offspring. If there are multiple lines off a mating, there's multiple offspring. They're always going to be ranked oldest to youngest. So this guy is going to be older than his sister. If there is a line through it, unfortunately, that means that that member of the family is deceased. Okay, so key term, pedigree, is the diagram that shows the genetic relationship between individuals and traces specific traits within a family. So practice with pedigree. So we are going to build the Smith family pedigree. Okay, I know that this might be a little confusing. I'm going to walk it through you and then I'm going to show you what it should look like and you can correct whatever you did if you made any mistakes. So first, we're going to begin with a couple named John and Jane. John is going to be square and Jane is going to be a circle. They should be drawn in the middle of the page and connected with a horizontal line. This indicates a mating. On a pedigree, this shows that they have had children together. John and Jane have 2 children, a boy and a girl. So that means the boy is, their oldest is a boy, so he will be drawn on the left, and the symbol for girl will be drawn on the right. They should be drawn as branches off of a line that is connected to the line between their parents. Next, work out the information. So on one member of the couple, we will start with Jane. She is the oldest of 3 girls, so we will put her sisters next to her. So now we're adding the branch above John and Jane. So we'll put her sisters next to her on the same level on the page and connect them to the branches from a column and line. This will show that they are siblings. And of course, these 3 women have parents, so we will connect them to each other directly with a horizontal line and to their children with a vertical line. So John, Jane, connected. Their 2 children, Jane's sisters, and their parents. Awesome. So we're going to go back to this and we're going to finish the rest. So the only other information we know about Jane's family is that her younger sister is married and has 2 daughters. To show this, we connect the sister on the far right to a male with a horizontal line, and we show their children as branches off a vertical line. These children should be drawn on the same level of the page as the children of John and Jane because they are in the same generation. So if John and Jane were your parents, these would be your cousins. Now we move on to John's side of the family. He is the youngest of 4 children. The oldest is a boy, followed by a girl, then another boy, then another, or then John. We connected them as branches off a single line to show they are siblings. Next, we put in John's parents. So we're going to go over here. We're going to add in Jane's sister's husband and the cousins. And we're adding in John's siblings and their parents. Okay. Finally, we add that John's oldest brother is married with 1 son. To show this, we connect him to a wife with a horizontal line and draw a line down to their son. Notice that the lines do not have any branches because they just have 1 child. Now the pedigree is complete with all the information we have. All the people in the same generation should be level with one another on the page. So this is our complete pedigree. John's brother's wife and the cousin on the father's side. So grandparents, parents, children. Okay, this is the Smith family pedigree. We are not quite done yet. So this is just who they are related to. We haven't tracked any traits yet. Okay, so how to indicate traits on a pedigree. So once a pedigree has been constructed, or even as it is being constructed, the trait of interest is added. Let's go back to our Smith family pedigree. We want to see who in the Smith family has dimples. So we're going to shade in the individuals who have dimples. So both John and Jane have dimples, but neither of their children do. The only other people on Jane's side of the family who have dimples are her father and youngest sister. On John's side of his family, his mother and sister have dimples. So on John's side, John and Jane have dimples. Yeah, Jane's youngest sister has dimples, and John's sister has dimples. His mother and Jane's father. Okay, so here we're tracking who has dimples in the family. Take a picture of your finished pedigree and follow the directions on the doodle sheet to insert it into the document. So you can take a picture and insert it in. You can try and draw it in, whatever makes you happy. As long as I can see that on the doodle sheet, you are done. Okay, I believe this is the last slide of this Screencastify. I'll be working on more throughout the week. So key term, carrier, is the person who is not affected with a trait but can pass it down to future generations. So this is how traits skip generations. So even though these guys didn't express the trait of having dimples, so they don't show that they have dimples, their children will likely have dimples. It can be passed on to them. They are carriers because they're carrying that marker. It's just not prominent. Okay, so that is it for today. I will be recording the next Screencastify, hopefully tomorrow, maybe today if I can get started on it. But we're all done. I hope you guys have a wonderful day.